Hello everyone. So kule video sizodiscussa ama-solutions wala ma-questions engiwasendile. So lana sino 4.2 says the graph of an increasing exponential function with equation f of x is equals to a b to the power x plus q has the following properties. The range is y greater than -3, and then we also have these 2 points that lie on the graph of f, right? So now they want us to determine the equation that defines f. So 4.2.1, they want us to determine the equation that defines f, meaning now we need to solve for the values of a, b, and q lapha kule equation yethu yaka f of x, right? So 4.2.1 f of x, f of x is equals to a times b to the power x plus q, right? So now we have to solve for a, b, and q, right? So now notice ukuthi they give us the range of this exponential function. Because we have the range, we can also know the equation or the equation of the asymptote, right? The range of an exponential function will also tell us about the asymptote. If they say y is greater than -3, it means the graph can never cross below the line y equals to -3. So the line y equals to -3, the line y equals to -3 will be our equation of the asymptote, right? Now this equation of the asymptote, or the asymptote, will also tell us about the value of q, right? Remember when we started, we said the value of q also determines the asymptote for an exponential function, right? So knowing that the equation of the asymptote is y equals to -3, I know the value of q is -3. Okay, and then now our equation will become f of x is equals to a times b to the power x minus 3. And then now I can use these 2 points to solve for a and b, right? Using the first point, we know when x is 0, then y is -2, meaning when we substitute 0 where we see x, we'll have a times b to the power 0 minus 3 is equals to -2, right? And then we know anything raised to the power 0 is 1. So now my equation will become a minus 3 is equals to -2, and then meaning a will be equals to 1, right? So now my equation will become f of x is equals to b to the power x minus 3, because a is 1, right? And then now I can use this point to solve for the value of b, right? So when x is 1, y is -1, meaning when I substitute 1 in my equation, I should get -1, right? So now replacing x with -1, I will have b raised to the power -1. Sorry, I'll have b raised to the power 1, which is just b, and then -3 should be equals to -1, right? Then solving for b, b is equals to 2. So now my equation is f of x is equals to 2 to the power x minus 3, right? That is 4.2.1. So 4.2.2, they want us to describe the transformation from f of x to h of x, where h of x is the function 2 times 2 to the power 2x plus 1, right? Now let us start with the value of the asymptote, or the value of q. Notice to move from the, okay, let us have a smaller sketch here, right? So now our function f has an asymptote at y equals to -3, right? So our asymptote is somewhere here, -3, right? And our graph has an x-intercept, a y-intercept at when you substitute 0 there, we'll get 1 minus 3, which is minus 2. It has a y-intercept at minus 2, meaning our function will look like this, right? So again, when check when you are calculating the value of b, they told you what this is an increasing exponential function. So nabakutshela lokhu, you should know ukuthi b has to be greater than 1. If it happens ukuthi lana uthola ukuthi maybe b is equals to 1 over 2, then you know immediately ukuthi b wakho wrong, because they told you ukuthi this is an increasing function, right? So now to describe this transformation, to move from this value of the asymptote minus 3 to the asymptote 1, what did we do to this asymptote to get to that one? Notice if you shift this one 4 units up, you will end up at 1, right? So now to move from minus 3 to 1, we added 4, which means it's a shift of 4 units up, right? We have to shift, right? We shifted f of x 4 units up, okay? And then when you shift f of x 4 units up, you'll have f of x is equals to 2 to the power x plus 1, right? So now we have to find out what happened ukuthi babe no 2 lapha, ne? So now ukuthi babe no 2, when they shifted 4 units up, the function would sort of come to this point, right? When they shift 4 units up, right? And then now, it has to be at this point somewhere there, right? It has to be somewhere there, and then the y-intercept will go from minus 2 to 2, and then now to get this 2 here, they shifted the graph f of x is equals to 2 to the power x plus 1 unit to the left, right? So now the graph will shift, and then the graph will shift, and then the y-intercept will move from 2 to 3. It's a shift of 1 unit. It's a shift of 1 unit to the left, right? It's a shift of 1 unit to the left. When I say h of 0, I'll have 2 times 2 to the power 0 plus 1, which is 2 plus 1, which is 3, meaning the y-intercept has to be 3 for this function, right? Meaning if you shift this graph here, if you shift this graph 1 unit to the left, you'll have, this let us pick another point lapha kule graph. Let us pick, so we know what this point is 0 1, ne? And then okay, so athi sidrowe kabutsha, right? Manje ngifuna ukudrowa isketch sale graph f of x is equals to 2 to the power x plus 1, right? This is a shift of okay, let me choose another letter here. Let's say this is g of x equals to 2 to the power x plus 1, right? This is a shift of this function by 4 units up. right? Meaning here our asymptote will go from -3 to -1 to 1, right? We'll go from -3 to 1. So we'll go from -3 to 1, right? So this is 1, and then the y-intercept will go from -2 to 2. It will be somewhere there. Okay, so a graph G will look like this, right? This is the first part of the transformation where we shifted a graph f of x 4 units up, right? And then now we want to explain u2 lo yalapha multiplying I, right? So mina ngithi u2 lo will come in when you shift the graph G 1 unit to the left, ne? Ngazi njani ukuthi you shift 1 unit to the left? If I have another point here, let's say this point is 1, and then when you substitute 1 there, you'll get 3. So this point is 1, 3. When you shift this point 1 unit to the left, it will come here, ne? It will go there, right? And then this one is 0. It's 0, 2. This one will go from 0, 2 to -1, 2. And then your graph of h will still have the asymptote at 1, but then your y-intercept will now be at 3. So to know what the asymptote is at, the y-intercept is at 3, substitute 0 lapha ku graph of h, uzothola ukuthi you'll get 3. So that's how I know what it shifted 1 unit to the left, right? Okay, let us go to question 5. So okay, question 5, we have a sketch below which is the graph of g equals to k to the power x, where k is greater than 0 and y is the inverse of g, and the point, this point lies on the graph of g. Question 5.1.1, they want us to determine the value of k, right? That should be easy. 5.1.1, to determine the value of k, you can pick this point and substitute in your graph of g, right, in your function of g. So if x is 2, y should be 36, ne? Meaning when you substitute 2 where you see x, you should get 36, right? And then taking this positive square root of 36, you should get that k is equals to 6, right? And then 5.1.2, okay, let me, I think probably 5.1.2 here. 5.1.2, they want us to give the equation of the inverse of g, right? I'm sure we know by now what to get the equation of the inverse, you swap x and y, right? So the g, we know what is y equals to 6 to the power x, and then now to get the inverse function, you swap x and y. Where you see y, you put x, and when you see x, you put y. And then now you solve for y. You'll have y is equals to log 6x. This will be your inverse function. Okay, and then 5.1.3, they want us to determine the values of x for which the inverse function is less than or equals to 0. Notice ukuthi the inverse function is this one, ne? It is equals to 0 at this point. That is the x-intercept, right? Now to determine the values where g of x is less than 0, you'll have to see where does this graph of g lie below the x-axis. It lies below the x-axis from moving from this point 1 0 going to the left, right? So if we sort of like zoom in this part, we'll have something like this, ne? Let's say this is the graph of the inverse, and then this point is 1 0, right? At 1 the graph is 0, right? Now we are interested in the parts where the graph is less than 0 and equals to 0. We know what it equals to 0 at this point when x is equals to 1, and then we also need the points where the graph is less than 0. The graph will be less than 0. The graph is less than 0 below the x-axis, so this part is where the graph is less than 0. So notice the corresponding x values are these ones here. So in this region the graph is less than 0, and these are the corresponding x values, right? So the values of x for which the graph is less than or equals to 0 will be the values between 1 and 0. Notice we are not including 0 because x equals to 0 is the equation of the asymptote for the inverse. So you cannot do this, right? You cannot have x be 0. Okay, 5.1.2, 5.1.4, sorry. But write down the equation of h if h is g inverse x minus 3. So now to get the equation of h, notice they shifted the inverse function 3 units to the right, right? So it means the asymptote will go from x equals to 0 to x equals to 3, ne? So now the domain of x equals to, the domain will become, okay, the domain of the inverse function, this one, is x greater than 0 because the function has an asymptote at x equals to 0. Ne? So now when you shift the asymptote from x equals to 0 to x equals to 3, your graph will shift and sort of look like this. Let's say this is x equals to 3. So the graph will exist from 3 going to the right. So your domain will be x greater than 3. And then 5.2.1, but sketch the graph of the inverse of y equals to 1. The inverse of y equals to 1 is x equals to 1. Remember, to get the inverse you just swap x and y. Where you see y you put x, right? So now to sketch this graph we just gonna draw a vertical line where x is equals to 1. So this will be the graph of the inverse. Okay, and then 5.2.2, they want us to button. But is the inverse of this function a function? Motivate your answer. We'll say no, it is not a function because it fails the vertical line test. Notice when you're drawing vertical lines, and then when you draw vertical lines here, you'll sort of have one x value corresponding to multiple y values. So this is not a function because it is a one-to-many relation. I hope that makes sense. So we'll say no, it is not a function because it fails the vertical line test, right? Okay, and then yeah, we're done answering these questions. So if ukunala ungazwisisi khona, please ngisatsho na nje ukuthi ungasabi ukungibuza. I mean abaningi benu abangibuza ngazi ukuthi why, but ngiyakhona ukubona ukuthi abazwisisi. so ngitshele ukuthi yini leyo ungayizwisisi and then ngikhona ukukuchazela kuhle ukuthi kumele wenzeni, right? So yeah, so after this after this revision lesson, we will have one more la sisolva khona ama-questions wama exponential and inverse functions, and then after that one we will discuss calculus and cubic functions. So before we move on to calculus and cubic functions, make sure that you are comfortable with this section here, my exponential and inverse functions. These are 3 marks, guys. Ngakutshela kusese nje ukuthi ama marks lawo ungawathola wonke if you know what you're doing and if you understand like ama basics, njengokuthi when you want to determine an inverse function, you just swap x and y and then make y the subject of the formula, right? Section le kufanele ibe straightforward. If it's not straightforward kuwe, ngisacela ukuthi ukhulume nami ungitshele ukuthi yini ekuhluphako, kuphi la ungazwisisi khona, ungasabi ukungibuza, right? Ngikhona la ukusiza wena, so ngicela ungitshele ukuthi ukuphi la ungazwisisi khona. Yeah, okay.